Alright, again, I'm going to do this a little bit differently, and I have no problem if you want me giving you a copy of this when I'm done. I'd rather have you watch. I just copied everything over from BMI to a new folder called Calculator. Okay? And I'm going to change the name of this to Calculator.html, and I'm going to change the name of this to Calculator.js. With me? Alright. Now I'm going to have to make a change in the other one. I'm not worried about that right now. I'm going to open this up. Okay, and I'm getting rid of everything that's in it. So I'm going to put a comment here that says a JavaScript calculator which includes the use of functions. And again, if you want this one, I'm done, fine. If you don't, I don't care. So a function main. Now, does this make, I'm asking you, does this make sense to you? We want our calculator to do 5 things. We're going to input 2 numbers. We want to add them, subtract one from the other, multiply one by the other, divide one by the other, and also do the remainder operation. And if you don't know what that is, don't worry, you're going to see it right now. Does that make sense? All right. But the way that we're going to do it is we are going to modularize this. Okay? What does that mean? Well, I'm going to show you right now. So I'm going to come in here and I'm going to say this. First, I'm going to declare and initialize variables. Okay, so var number 1, set that equal to 0. Var number 2, set that equal to 0. Now, I could make it 0.0. Who cares? I'm just going to assume right now that this is a simple calculator where you're going to give it 2 whole numbers. Does that make sense? All right. Var sum equals 0. And what is that? That is number 1 plus number 2. Okay? Var diff, I'm just going to call that instead of difference, equals 0. And that's going to be number 1 minus number 2. So I'll put comments here too. First number input second number input. All right, so what's left of our product? I'm just going to call it prod, and I'm going to set that equal to 0, and that's number 1 times number 2. Then I'm going to have var, it's the quotient. Now look at this. This one will be different. I'm going to set that equal to 0.0. It's not impossible that we could have, if I divide 7 by 3, I want it to be 2.333. Does that make sense? All right. So this one will be number 1 divided by number 2. And the last one, I'm just going to call it mod. It's the remainder. And I'll set that equal to 0 as well. And that will be number 1 modulo. We use a percent sign, number 2. And I'll explain to you how that's used in just a minute. Okay? Those are our variables. Look on the screen both. Is there anything there that doesn't make sense? We're going to do the mod. We're going to go over it in a minute.
Well, is the division right?
Yes, for quotient. All right. Yep. And I'm going to have here var, like we had been doing. I'm going to call this again, and I'm going to set that equal to true, meaning that's my program continue variable. All right. And var first, just calling it first. I don't want it to be first child. I'm just going to say first equals, and that's going to be equal to nothing. And that'll be my first character. And if you don't understand what that means, you will in a minute. Okay? Now, what we're going to do, normally we'd come in here and we'd input our two numbers, right? Then we'd say sum equal number 1 plus number 2. Diff equals number 1 minus, etc. We do that. But we're going to modularize this. You say, I don't know what that means. Remember with me, I remember because it was Mrs. Dimmick in 4th grade. We had to learn how to write book reports. Okay? And she wanted them written in a certain way. Roman numeral 1, A, B, C, D, numbers underneath there, letters, etc. Remember that kind of stuff? That's modularizing. That's taking a job, or I'll always remember this. For about a year and a half, I rented a house from a guy. It was a house behind his house. It was 1 bedroom, literally. The shower was down in the basement. It was not a big house. Probably the total square feet with the basement was maybe 500 square feet. So it was not big. But sometimes I'd come home and the house was a real pigsty. So I'd say, I'm going to clean it. No, I'm too tired. So I would fool myself. I'd say, well, let's break it up into pieces. So I would clean the kitchen. Then I would clean the living room. Then I would clean the bedroom. See what I'm saying? That's what we're doing here. All right, so we're going to come in here and we're going to say while, again, meaning as long as we want to keep going, but it's going to be different from what we've been doing before. All right, I'm going to call a routine we haven't written yet. Did you hear me? I'm going to call this input number 1. So I'm going to say number 1 equals input number 1. Number 2 equals input number 2. Sum equals add 2, and I'm going to give it number 1, and I'm going to give it number 2. There's a short in the chord. All right, diff equals sub 2. I'll just call it the same thing. Diff 2. Number 1, number 2. Prod equals prod 2. Number 1, number 2. Quote. All right, let me just finish this and then I'll go back and do it. He's already replaced this once. Plugs aren't expensive, but he's got to order them out when he needs a new one. I'm going to have to ask Charles, what does he want me to do with this? case. All right, again, rather than putting all this in one routine, I'm going to put it into 1 for main, then I'm going to put it into 2, 3, 4, 5, 6, 7, 8, 9 different routines. And again, you might say, why are you doing all that work? In this case, it's not a big thing because the routines will be real small. All right? But what you'll notice is as these programs get bigger, it makes sense to break them up into pieces. So, oops. Outside of main, now I'm going to have my second function. So function input number. And guess what? You already know how to write this. So what am I going to do? I'm going to say var num. In fact, I'm just going to call this input number. And that way I can call that input number and that input number. All right. Num equals parse int prompt enter a number. That's it. And we'll default it to 10. Why? I just made that up. I don't care. So, while is NaN num, that's the only thing we're checking for. While it's not a number, we're going to ask you to do it again. Does that make sense? So again, when you get down to right here, you put in a number. Return num. Play computer. So I come in here and I say number 1 is equal to this. Control switches from here down to here. And it says enter a number. If you leave it at 10, for example, it says cool, that's a number, and it returns 10. And it takes that 10 and it puts it inside of here. Does that make sense? And we ask it to do it again. Call the same routine. So we call this routine twice and we'll put in 2 numbers. We'll look at that in just a minute. Now look what we've got. Sum, diff, prod, quote, mod. So we got 5 routines that are pretty much the same routine. What do I mean? We're going to write here function, and we call the first one add 2, and we've got number 1 and we got number 2, and we just say return n1 plus n2. That's our first one. All right. Then our second one is called diff2, and it's return n1 minus n2. Then our next one is called prod2, and that's n1 times n2. Now the next one is different. Look on the screen, please. So we call this quote 2. All right. This is all fine. See that? That's all fine. Except what if number 2 is 0? You can't technically divide a number by 0 because the answer is infinity. Does that make sense? So I'm going to check this first. And I'm going to say if n2 equals 0, because 1 equal means assign. If we only put 1 there, that would take 0 and assign it to n2. We don't want to do that. So when you test, it's 2 of them. So if it's equal to 0, then I'm going to return, I'm going to just put illegal attempt to divide by 0. So that's literally what I'm going to do. I'm going to return that. If you say I don't know what that means, you will in a minute. Otherwise, I want to return this. All right? When I get done with this, I'm going to print it out so you've each got a copy. All right, then this was called mod2. The good news is, it's quite a bit of code. All these have now been written. Every one of those has been written. All right? So the only thing that's left is this one, print answers. And this is too much to type, so N1, N2, sum, difference, product, quotient, modulo. Now, this is the first number we input. This is the second number input. That's num1 plus num2, num1 minus num2, num1 times num2, num1 divided by num2, num1 modulo num2. Does all that make sense? All right. So I'm going to do this a little bit different because I hate that when we've got all of those adding a backslash n, etc. So I'm going to come in here. I'm going to say var string. I'll just call it str for string equals nothing. Okay. And then str equals, and I'm going to put in here, let's see, n1. This is going to look really weird. Plus n2 n1 plus n2 equals so. I don't expect that to make a lot of sense, but if we put in 10 for number 1, 5 for number 2, that, if I did it right, should say 10 plus 5 equals 15. Does that make sense? All right. And I want to add on to this. We will put a plus backslash n backslash n. All right, and I'm just going to keep copying this, and I'm just going to change the sign. So that's going to say minus. The next one's going to say times. The next one's going to say divide. And the last one is going to say modulo. Means add to it. We're going to go over exactly what that means in just a second. All right. Now that we've got all that, now all I have to say is alert str. Now, again, as always, could I have made mistakes? Of course I could have. But let's look at what we've got and run it and see if it works. And then I'm going to print out a copy of this for each of you so we can look at it and go through it line by line. So when you've got questions like that, hopefully they'll make some sense. All right, good morning. So this is now not a test anymore. This is just JavaScript calculator. And this is also called calculator. All right, let's try to run it and see what happens. Okay, doesn't like something. Line 42. Not worried about the other one, I'm worried about this one. So line 42. Yep, I always do that. Forget that. Forget that. Let's try it again. I don't know why I keep getting that unexpected token thing, but we do. 44, 13 in here. Usually when you fix all the other errors, this one goes away. So while I can already tell I'm missing a parenthesis there, let's try it again. Unexpected string, line 90. This is what happens when I do things right off, literally off the top of my head. I make more than my share of mistakes. str equals n1.
Oh, the S only has one. Well, I don't know if that's
Let's see if that fixed it. Now, in a couple minutes, when we start going over this, ideally at least, what's going to happen is you're going to say, oh, you meant that's when you meant this, that's when you meant this type of thing. All right, like I said, hopefully. So n1 plus sign plus n2 plus n1 plus n2 equals, now we need our answer, equals s d p q m. All right, so enter a number, 10. Enter another number. Let's put 5 in there. Okay, well, it worked that far. So there's still something in here it doesn't like. Line 29 in JS. The reason that this is actually a good thing, I've already mentioned it to you, but just so you hear it again, all right, that is that when you take your next test, I'm going to give you a program that's filled with errors. I'm going to tell you how many errors are in it, and that's going to be half of your grade, is to figure out what those errors are. All right, number 1, number 2, sum, diff, prod. Look at this. Look on the screen. See this? Quote. Look what I wrote there. Put an E in there. That'll screw it up. All right. 10. 5. See what we got? We just made a little calculator. Now, also notice that when we do this, if I run it again, yes, I want to run it again. 10. Now I'm going to put in 0. You can't divide by 0. So notice what it says. See that? Illegal attempt to divide by 0. All right. So let's do this. No, I don't want to do it again. I'm going to give you each a copy of this. Maya, that thing that we did in class that I asked you to do, you never sent me those. Pages 89 and 101 or whatever it was from chapters 2 and 3. You did the first assignment, but you didn't send me the second one.
What do you mean the second one?
I asked you to copy in a couple that were in your book.
101 and 79?
Something like that. Whatever it was, I didn't get it. I'll have to double check to make sure.
It's in my site. October 27th. I don't know if that was a different
So
one.
here, yeah, I'll have to look. There were two assignments. Like I said, it could be from other pages. I don't remember. All right. So we got that one. Let me get the other one for you. Right. All right. So you've got both the JavaScript and you've got the HTML, right? So now let's jump back. Let's jump back and start going through the chapter.
So that was what's on chapter 4? Was that
One of the big things on chapter 4 is functions. All right. Some of the stuff that's in here we've talked about at least a little bit. Some of this object stuff, we'll look at that in a minute. The events, we'll start looking at events. This is probably going to be the hardest thing. That part in chapter 6 will probably be the hardest part of the book for both of you. All right. So it says in the last 2 chapters, you learn how to code some simple but unrealistic applications using prompt and alert. In this chapter, we'll work with objects, functions, and events. So if you notice what's in the chapter here, this is the big thing we're going to be talking about. Next, we're going to go in and start talking about how to handle events. We're going to look at that more in depth tomorrow. All right? And then we'll look at these 2 illustrated programs. They're going to redo the miles per gallon and make it look a little bit more professional, let's say. All right. So far, you've learned how to use prompt and you've learned how to use alert. All right. There's another one that's really not used very often. It's called confirm. And confirm, when you use confirm, it brings up a dialog box and it's got an OK button in it and it's got a cancel button in it. One of the ways we could be doing this is we could be asking the user, would you like to continue the program? And we could have a confirm in there. And if you clicked OK, it would run again. If you click cancel, it would be over. I'm not doing it that way. All right. And the reason that I'm having it, if you look up on the screen here, the reason I'm having you run yours like this is JavaScript is one of the few programming languages that has a confirm. Most languages, you will write it like this. That's why I'm having you do it like that. You're going to see that again when we go on to the C# language in spring. All right. You already know, do you have at least a pretty good understanding of what parseInt and parseFloat are?
Kind of.
What's the difference between parseInt and parseFloat? ParseFloat, you can have a decimal. Yes. All right. You typically use it along with a prompt. And here, notice they say you could do it as 2 lines of code, and you can. Totally fine. I've been showing it to you as a single line of code rather than 2 lines. I just think it's easier. If you don't agree, if you think what they're showing up on the screen right here is easier writing it as 2 lines as opposed to 1, write it as 2. Totally fine. All right. Now, notice it's got here 3 elements of the document object. I'm just telling you right now. Call it a warning, call it whatever you want. See this thing right here, get element by ID? That's the hardest part of learning JavaScript. All right? We're going to start going over it a little bit today, and we're going to go over it in more depth and breadth of coverage tomorrow. All right? Right and right line are not hard. If I want to write something on the screen, I can do a document.write. Let's say that I wanted to write on the screen, how are you? If I wrote document.write, double quote, how are you? If I wrote that on the screen, what you'd see on the screen would be this. How are you? Exactly what you think. But your cursor would be right there. See that? Typically that's not what you want. You might want the cursor on another line so you can answer the question down here. And if instead of right, you write right line, LN, that moves the cursor, that moves the cursor down a line. That's the only difference between right and right line, is right keeps the cursor on the same line you're on, right line puts you on a new line. Other than that, they're the same. All right. So what's new in here? The window object itself, document.write. Don't worry real much about the window object until Chapter 6. That's what Chapter 6 is all about. Is that the right line thing you're talking about too? All that right line allows you to do is to write something right on the web page itself. That's it, on the web page. So far, when we used our alerts and we used our prompts, we get the little boxes up at the top of the screen, right? As soon as you put something in there, they go away. If you would do a document.write or a document.write line, they're on the web page as long as you keep them there. So if you want something to stay on the page, you do it that way. All right. Again, the document object model, the DOM, is what Chapter 6 is all about. So really don't worry about it until Chapter 6. And that's a hard chapter. I'm not going to lie to you, but we'll spend much more time on it then. Parse int and parse float. NaN, you know, stands for not a number. All right. When we use this get element by ID, which we will, when we use that, all right, that's why we give things on our web page. Remember when we used ID equals and class equals? Not only is there a get element by ID, there's another one called get elements with an S on the end by class name. All right, so we'll be able to use those IDs and those class names that we were working on previously. All right. Now, you already know what a text box is. When we were in Chapter 11 and we said input equal text, it made those text boxes for us. Remember when we made the forms? That's what they're talking about here. All right. When you do that, if you want the cursor to be at a current, at some text box, you can do what's called setting the focus. You're going to see an example of it in just a bit. All right. Value is what's inside of that text box. That's what's inside of it. It's value. Disabled. Do I have to tell you what disabled means? Have you ever gone to click someplace and it's gray and you can't put your mouse in there? That's disabled.
What's a Boolean?
Boolean, again, we talked about this before. A Boolean is true or false. If disabled is true, you can't enter a value in there. If disabled is false, you can enter a value in there. To fixed, we've talked about. How many decimal places do you want? Again, when you look at these, they talk here about using this with chaining. Don't worry about it right now. There'll be nothing on your next test with this. It'll be on the test afterward. All right? And by that time, we'll have actually written, and we're going to start putting our JavaScript into our website. All right? Okay. JavaScript allows you to make things that are dates and strings. You know, if you look on the screen here, we just went over this one, right? Just so you know, anything in JavaScript that you do with two quotes, if you want to, you can do it just with one. So you have your choice. You can use 2 quotes or 1. The reason I use 2 almost all the time, JavaScript is pretty unique like that. In most other languages, you need to use 2 quotes. That's why I use 2 quotes. So you get in the habit of doing it that way, because that's the way it'll be. For instance, in C#, you can't use 1 quote like that. You need to put it in 2 quotes if it's a string. All right. If you work with a date, you can pluck out just the pieces you want from the date. What a date gives you, so if I ran the date command right now, if you look on the screen, it's 9:53. It would say 09 colon 53 colon, let's say it was 17 seconds, 17 colon 23. It gives you the time to within 100th of a second. And it would give you not just the time, it would give you the date and the time. So you'd get all that stuff. And again, you can pick off whatever you want to pick off from it. All right? Some of this you've already looked at. I've had you use the 2 lowercase or the 2 uppercase. We use the 2 uppercase. Remember, if you put in yes or no, and I only wanted to check for a capital Y, I use the 2 uppercase on it. All right? Again, there are examples in here of this stuff. So the next thing is functions. That's what we just did. So as it says, a function is a block of statements that performs an action. This is the key word right there. A single action. If I'm asking you for 10 pieces of information, first name, middle name, last name, address, city, state, zip code, cell phone number, email address, that's 9. Let's just say those 9. In a truly functionalized world, you would write that as 9 different routines. Why would you write that as 9 different routines? That way, if you screw up someplace, let's say for some reason the email isn't working, you know exactly where to go to fix it, because you've got a routine that just handles email. So in much the same way, look at the example that we just went over. Let's pretend for a second. Let's just pretend that in the difference here, I made that a plus. See that? I made that a plus. I'm not going to do it, but let's pretend I made it a plus. Now it's going to say 10 minus 5 equal 15, which would be wrong, right? But I'd know right where to go to fix it. It would have to be in this routine. So you modularize things. You break them into components so that when you have problems, you know right where to go to fix them. And each one of these routines is doing one and only one thing. So they've got their own things in here. They've got their own examples. Again, when we get into Chapter 6, we'll talk about this. All right? You are going to see an example of it later on in the chapter, some of this stuff. I am not going to give you anything in this chapter that deals with what's called the DOM, or the Document Object Model. For 4 and 5, it will not be on your test. When we have Chapter 6, that's what most of your test will be on. All right, just so you've been told that. All right. So, how to declare a function. Function, followed by the function name, and anything that the function needs. All right. I've given this example before. So let's just say that my daughter, I have one daughter still living with me. Let's just say that she comes home, and I'm in a real bad mood anyway, and I realize her room looks like a pigsty. All right? So I say to her, Mackenzie, clean the room. Well, Mackenzie is a great kid, but can be a good smartass. What room, Dad? I'd say, clean your room. So in other words, she needs to know what room to clean. Does that make sense? That's a parameter. That's information that the function needs in order to be able to do its job. So what we're going to do tomorrow, what we're going to do is we are going to go back to the payroll program and rewrite that. We're going to rewrite it using functions. Right? Okay. Now, this is local and global variables. Look on the screen, please. If I write something that is outside of any function, not in main, not in anything, it's global. But notice I've got a routine here, and this routine, I know, again, I don't want to go into what all this stuff means. But if I create something in between these two curly braces, see that? It's what's called local. Means it's only known within those two curly braces. All right? If I create something outside of any curly braces, it's global, meaning you can all use it. In some programming language, what they say is if you create something outside of everything else, it's what's called public. Now, I realize this isn't how it works, but technically, I should be able to get in my car, drive to Washington, D.C., ring the doorbell in the White House and say, I'm a constituent, I want lunch with Donald Trump. I know it's not going to work, but the idea is with him being a public figure, he should be accessible to everyone. Does that make sense? The reverse wouldn't work. If somebody comes to my house and says, hey, I don't know you or anything like that, but I want to come in and I want you to make me dinner. There's probably going to be a bigger problem that way because I'm private. So when you create something inside of a routine, if that confuses you, look on the screen, please. All right? If we were to have created here, we're inside of this routine. See where we say this, var num? We're creating a brand new variable. That variable is only alive within this routine. Now we do grab it, make a copy of it, and then stuff it into here and stuff it into here. But after we do that, num is dead. It does not exist anymore. All right? JavaScript has a thing you can use that's called Strictmode. Look up on the screen, please. We're going to start putting this at the top of our programs. I think I told you this before, but one thing about JavaScript is it allows you to develop some kind of bad programming habits. It allows you to do things you really shouldn't do. Why? Because you can't do them in other languages. But JavaScript is one of the most forgiving languages there is. All right? When you put at the top of your JavaScript program, use strict, what it does is it attempts to take this liberal JavaScript, make it a little more conservative. It'll look for certain errors that when it can't find things, it's like, oh, you probably mean this. No, I'm not going to assume that. And it'll flag it as an error. But what it does by putting in use strict is it makes you a better programmer because you have to write things correctly from the beginning. So that's why we're going to use that. Okay, fairly soon. All right. The next thing that's in here, again, this is tough. This is more on Chapter 6, but we are going to look at it in here. It's called event handlers. JavaScript is an example of a programming language that is what's called event-driven. All right, what does that mean? It means JavaScript sits there, and if you on your screen, this is going to almost sound like I'm making a joke or whatever. It's not funny. I don't think it is, at least. Okay? Okay, I'm going to run this program, the one we just did. Okay? If I sit there and never click that button, what's going to happen? Nothing. Because JavaScript is event-driven. When I click the button, it says, oh, button click event. I better handle it. Does that make sense?
No.
All right. Many programming languages are event-driven. JavaScript is an example of one of them. Now, these are things that you can attach events to. You can tell the system as soon as the document gets loaded in the browser, you can put something in the Windows load event. The one you use most often is the buttons click event. That's the one we're going to use almost exclusively. But some of the code that you put in here can be pretty complex. We're going to look at an example of this in a little bit. So the chapter ends, and this is what we're going to do after the break. We're going to look at these two things that are in here. This miles per gallon and this email application. All right. During the break, I'm going to email both of those to you, so you'll have an electronic copy. All right. And we're going to, so you don't have to type them in, but we're going to look at both of those. All right. And that is the rest of the chapter. So we'll do that after the break. It's 10:03. Let's please come back at 10:15. All right. And then once we do, we'll look at that. We'll quickly go over chapter 5, and then we'll look at taking that test for chapter 2. All right. So take a break, please.